All right, welcome to The Explainer. We are surrounded by so much technology that just works. But have you ever really stopped to wonder how? Today, we're going to pull back the curtain on what is honestly a modern miracle: how your phone stays connected even when you're on the move.
I mean, seriously, think about it for a second. You're on a video call, you walk out of your house, and your phone switches from Wi-Fi to cellular without a single glitch. The call just keeps going. How is that seamless switch even possible? Well, it turns out that solving this is a way bigger technical challenge than you might think.
You see, the fundamental problem goes all the way back to the Internet's original design. Its core infrastructure, the Internet Protocol, or IP, was created for computers that were stationary. It just wasn't built for a world where our most important devices are in constant motion.
And here's the core of the issue. Back in the early days of the internet, your IP address did two jobs at once. It was both your device's identity, so who you are, and its location, where you are. Imagine if your street address was also your legal name. For a big desktop computer that never moves, hey, that system works just fine.
But the moment your device starts to move, that whole system falls apart. As you walk down the street, your location is changing, but your identity shouldn't. If your IP address changes to match your new location, the network suddenly has no idea who you are. It thinks you're a brand new device, and theoretically, your connection should be cut off instantly.
So to really understand how we solve this puzzle, we first need to learn the language of mobility. You know, when we talk about mobility, it can mean a couple of things. There's personal mobility, which is when your user profile moves between different devices, like from your laptop to your phone. But for today, we're zeroing in on terminal mobility, your actual device, your phone, your laptop, physically moving through the world. And the most critical moment in all of this is the handoff. This is the magic trick we're here to uncover. It's that completely invisible process of your phone passing its connection from one cell tower to the next, or even switching from 5G to Wi-Fi, all without you noticing a thing. The first big attempt to solve this was a protocol called Mobile IP. And, you know, it was really clever for its time, but as we're about to see, it was also a little bit clunky. Mobile IP basically put together a little team of agents to manage your connection. Think of the home agent as your digital home base. The foreign agent is like your host in a new location that you're visiting. And the care of address? That's the temporary guest pass they give your phone. So here's how it worked. When you'd enter a new network, your phone would get that temporary care of address. It would then have to send a message all the way back to its home agent, basically saying, hey, I'm over here now. Send all my mail to this new address. The home agent then intercepts all the data that was meant for your permanent IP and forwards it through a special data tunnel to your current location. But this system created a massive inefficiency. Just imagine you're in a coffee shop in Tokyo and you're trying to access a server that's also in Tokyo. With mobile IP, your data request has to travel all the way back to your home agent in, let's say, New York, only to be turned around and sent right back across the world to the server in Tokyo. It's pretty wild. This inefficiency is known as triangular routing, and it adds a ton of latency and really clogs up networks. I mean, it works, but it's far from ideal. It's like your data is being forced to take the long, scenic route every single time.
This whole triangular routing problem, it absolutely demanded a better way. So, engineers developed a much more elegant solution. And it's the one that powers our devices today.
The huge breakthrough came from a really simple shift in thinking. Engineers realized the problem wasn't the phone, it was the entire approach. So what was the solution? Take the burden of managing mobility off the device and give that job entirely to the network. This one insight is the core of our modern system, Proxy Mobile IP.
The modern approach just flips this whole thing on its head. Your phone is completely, blissfully unaware of all the complex handoffs happening. Why? Because the network's own routers and gateways detect your movement and manage everything behind the scenes. Your phone just gets to hold on to its single, permanent IP address as if it never moved at all. This new system has a new team, of course. You've got the Mobile Access Gateway, or MAG. This is the sharp-eyed router at the edge of the network that actually spots your phone moving. And then there's the Local Mobility Anchor, or LMA. This is the new, smarter home base that tunnels data directly to wherever the mag tells it you are. It's way faster, much more efficient, and totally invisible to your device.
So, what does all this tech actually look like in the real world? Let's see how it all works right there in your pocket, every single day. Get this. When you're walking through a dense city or even just a large building, you might be handed off between different network cells or Wi-Fi access points hundreds of times during a single video call, and you don't notice a thing. That is the power of a network-based solution. And this is exactly why all that efficiency is so critical. A person walking might hand off every few minutes. In a car, it's more like every few seconds. And on a high-speed train, you could be switching cells almost constantly. The old clunky method just couldn't keep up with that kind of pace. And looking ahead, mobility management is getting even smarter. Networks are starting to use AI and machine learning to actually predict your movements. This means that before you even enter a new cell, the network is already preparing the resources for your handoff, making the process faster than ever before. So a clever network-based solution is what keeps us all seamlessly connected today. But as our world gets faster and our demand for instant data just keeps growing, it leaves us with a final important question. What's the next great innovation we'll need to make sure our connections can always keep up with the pace of our lives? Thanks for joining us for this explainer.